like a cliff, you know, kind of a thing, right? Okay, so let's go ahead and solve this thing. We've got what are the components of gravity parallel and perpendicular to the plane? That's part A. And parallel to the plane, it's going to be 5 times 9.81 times cos of 26. Yeah? And we have 2 sig figs, so we're going to write down 4 sig figs, and that'll be enough. 5 times 9.81 times cos. I encourage you to calculate along with me, because that will keep you awake. 44.09 is what I think. Newtons. And then it says, what is the force parallel to the plane? That's going to be this guy, right? So it's going to be 5 times 9.81 times sine of 26 equals and that's 21.50. Okay, so that's part A. So put the stuff that's in blue in part A, and then you'll have like how to do it, right? And you can even draw the little vector components on there, right? And then now let's solve B. So B says, were the block to slide with no friction down the plane, what would be its acceleration? Is that proper English? Should we say, yeah, I think it is. Were it?
Were the block.
Were the block. It actually is. It's subjunctive. It's the only case in English where you use like were or something like that. If I were a rich man. People say if I was, it's colloquial, but the correct usage is. Okay, so here's what we do. For this problem, if it's a frictionless plane, right? The only force acting along the plane is that force, correct? And there is no other force. Okay? So we just write it like this. The only force is 21.50. That's the parallel force, right? Right? And that equals 5 times A. Right now we can solve for A. So that's easy. 21.50. And I get and what does it mean that it's negative? It's down the plane, right? Now you got to be careful, because if you say negative something down the plane, technically you're saying up the plane, right? So I'm going to write in parentheses down the plane, as if like it's the same thing, right? You know? Are we good on that one? So that's easy. That's how you figure out the acceleration down the plane. Remember that this had m in it, so it actually doesn't depend on m. If I had more mass here, I'd have more parallel force there, right? So ultimately, this ends up being mg sine theta equals ma. The mass will cancel, and it ends up being just g sine theta down the plane. Okay, and that's what it always is. And then let's see, that's B. So C says, what force would make the block slide up the plane with an acceleration of 2.4 meters per second squared, presumably up the plane, right? Couldn't you slide up the plane and accelerate down the plane? Yeah, you'd be slowing down and stopping, right? Okay, but let's assume that this thing is going faster and faster up the plane, that's the way the question's asked. Okay, so now we have an unknown force, and we know darn well that it's going to be up the plane. We know it'll be a positive force, but we're going to pretend like we don't know and treat it just like a unknown force, right? So some unknown force acting on it. But what do we do with unknown forces anyway? Make them positive, right? So what forces do we have acting on the plane? Parallel force. It's always there, always negative. Right? Okay. And then we say plus the unknown force, right? And then that equals 5.0 times, what's the acceleration? 2.4. Is it positive or negative? It's positive, just because it's positive on the sheet, or positive because it's up the plane? Up the plane positive, yeah. Yeah? And now we're good, right? We can solve that guy, can't we? F equals. You guys are being so quiet. Is that because I'm taping? That's right. Okay, does this mean just 33.5 in any direction? No. Or does it specifically mean up the plane? Yeah. All right, so you know. And on tests, I'm going to ask you that. What's the acceleration? Which direction is it specifically? So you'll need to commit yourself to some answer, right? Okay, so D says, are we good on C? Other questions on C? Okay, D, they get a little harder, right? D says, what force in what direction would make the block slide down the plane with an acceleration of 5.2 meters per second squared down the plane? Right, so now it's got to accelerate down the plane. It's got to accelerate down the plane at 5.2 meters per second squared, and there's some unknown force acting on it, right? Okay, so does anybody have any idea which way this force is? Down the plane. Why do you think so? Just because it's accelerating down the plane? But doesn't it accelerate down the plane if no force is acting on it? So it could be either way. It could be up the plane or down the plane, right? But how is there just somebody have a good criteria? At 5.2, right? So how do you? Yeah.
It's since the block is 5 kilograms.
Since the block is 5 kilograms.
Should be on our tracker. Does it have anything to do with the weight?
I don't. Well, it kind of does. It does have something to do with the weight and the mass. See, the beautiful thing here is that we don't need to know, by the way, which way the force is going to be, whether it's up the plane or down the plane. Okay, I've solved enough of these. Here's what I'm thinking. If without any help it accelerates at 4.3 down the plane, but it needs to accelerate faster down the plane, doesn't there need to be an additional force down the plane? Now, wouldn't it be neat if we didn't need to understand that? That the math would just fall out in our lap and be a negative answer? So let's just try it. Okay, so for D, we've got the same thing, right? We've got the parallel force down the plane, and we have an unknown force. This is going to be a different unknown force. These F's are different, right? Okay, and then what is we have 5 times what? 5.2. I'm hearing 5.2, but that's not right. There we go, negative 5.2. And the reason I'm repeating it is that this microphone here hears me, but it doesn't hear you. So we need like a room mic, or something. I don't know. Yeah, just scream. Ah! This is, by the way, a fun thing to do. If you ever see somebody talking on a cell phone in a public place, walk up really close and just walk up and just go, and then just walk away. And you know that they will spend the next 5 minutes talking to that person on the phone. They'll be like, no, I don't even know who it was. No, it's just some random guy. No, he just walked up to me. Yeah. No, Yeah. I've never really done that, but I'm very tempted sometimes. I have asked people whether they're insane or whether they have Bluetooth. That's kind of fun. Are you crazy? It'd be bad, though, if they really were crazy. They'd feel bad about being. Okay, so we can solve this, can't we? Has anybody solved it? Do they know? I just typed log, 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 apparently. Don't know why. I get that the force is negative 4.5. Yeah.
Why are we using the parallel instead of perpendicular? What's the difference between two of them and
The question is, why are we using parallel and we're not using this poor perpendicular course? This force is sitting on the bench, and it will sit on the bench forever because it's not acting along the plane, so things that are perpendicular to it don't affect it, right? Now, that's not exactly true because this force, this perpendicular force, actually causes this block to be pressed against the plane. So when you get in college, they'll teach you a model of friction that depends on that force, right? But it's not part of the IB curriculum. They cut it out like 5 years ago or something. But that force against the plane causes there to be more or less friction, right? More force, more friction, less force, less friction. And so it becomes, we can actually calculate the friction force, but we're not going to go there.